Hi everyone. So the goal of this video is to understand a little bit more advanced ideas related to energy. How do we calculate energy? How do we use the calculations to maybe figure out a missing variable? So this was the question that you've seen a couple of times now. You saw it on your pretest. I think I used it in an example in a previous video. And let me kind of go over a few things here. So I think the major thing I want to point out here is conservation of energy. It says that energy is never created or destroyed. So what I want you to notice is that the total energy for moment one, actually let's take a step back. Let's read what this question is actually saying. So we have a 1 kilogram block. It's attached to a spring. The spring is stretched 0.2 meters from its equilibrium, and then it's released. After a few seconds, moment three, the block is 0.15 meters from equilibrium. Complete the table below. So we have some numbers filled in already. We have some numbers here, but notice that we have a question mark. So we're supposed to fill in this number. And so basically the way this works is we have a block that usually sits right here, but then somehow it got stretched to here. We let it go. After the first maybe split second, the block moves here, and then it's going to start bouncing back and forth. And so a few seconds later, at moment three, we have a situation where the block is here and it's moving this way. All right, so we need to figure out what is the energy of the system. Well, we already know some numbers here. And the key idea I want you to look at is that the total energy, basically all we have to do is just add all these up. So 10 plus 0 plus 0. Well, that's a total of 10. So the total energy of the system is 10. Now the key idea here is that the total amount of energy will not change. So if we started with 10, we're going to end with 10. All right, so we have 5.6 plus 2, well that's 7.6. 7.6. All right, and so the question is, what is this number here? Well, we know we want it to add up to 10. So we could do 10 minus 7.6, and that will tell us our missing value. All right, and that's going to be equal to 2.4. Okay, so that is the number that goes here, 2.4. So that the total energy is still 10. All right, and that's what the conservation of energy says. All right, let's look at the next part. And we might have to remember a few of these numbers here. So I think we might need to know that this is 5.6. So when we go to the next slide, so as stated before, the block is 0.15 meters from equilibrium at moment 3. Find the spring constant for the spring, given that the potential energy of a spring that is stretched a distance of x can be represented as potential energy equals 1/2 kx squared. So what do we know from this problem? We know that the potential energy of the spring, let's see how quickly I can do this, because sometimes it just takes me a while to write this all out. But on the last page, I knew that my potential energy was 5.6. Let's see, I know my x is 0.15. That's how far the spring is from where it usually likes to sit. And it's asking me, what is the spring constant? K. All right, well, let's put this into our equation right here. We have 5.6 is equal to 1/2 times K, that's what we don't know, we're trying to find that, times 0.15 squared. Maybe I'll put this in parentheses so it's kind of easier to see what we're actually squaring here. Okay, so now here's where we might have to do a little bit of math. So we have to do the 0.15 squared, and then we have to handle the 1/2 as well. So let's start with the 0.15. 0.15 times 0.15. Okay, so that's 0.15 0.0225. Sorry, my writing is not very good. All right, and then that's 1/2 K. Okay, and that still equals to 5.6 over here, 5.6. Okay, so now what we can do is we can combine the 1/2 with the 0.0225. So we'll multiply that by 1/2. So we get 0.01125K is equal to 5.6. All right, and now the last step that we have to do is divide both sides by this number here. So we're going to divide this side by 0.0125. I think you guys can kind of see where I'm going here. I'm sorry if this is taking me a long time to write. Over here, do the same thing, divide both sides. And if you're pretty quick with math, you might already know what I'm doing here, and you might even be able to figure out the final answer before I even write it on the screen. But I'll just do it anyways. So K is equal to, all right, let's make sure. So this cancels out. So now we just have K is equal to 5.6 divided by 0.0121125. So 5.6 divided by 0.1125. Okay, that is 497, which is really maybe 498 if we round it, really close to 500. So I bet when this company made the spring, they were really trying to shoot for a spring constant of 500. Okay, and there you go. So if you have a problem like this, you can use the conservation of energy to find a missing value. You could also use these equations. You might get an equation that looks like this, and you might have enough information to figure out the missing value. Okay, it maybe takes a little bit of algebra, but you're going to probably have an energy number, and you might have some other information given to you, and then there's one number that you might not have. All right, do a little bit of algebra, and you could probably figure out that final number. All right, you'll have some problems like this, and if you can do problems like this, you can get an A on lesson 2.